Hi, Baliram Sunpir.
Hi, Sudhir Saravde.
We are going to demonstrate experiment on laser welding of two dissimilar metals using pulse NdYAG laser system. Before actual experimentation, let us see various components of this system. This machine consists of laser head and beam manipulation system and power unit supply. It is also associated with table motion controller. This is the laser head. This laser head is capable of delivering a average power of 200 watt and peak power of 15 kilowatt. This generated laser beam is passed to the workpiece through a laser manipulation system. Laser beam is generated inside the laser head through a flash chamber, hence lasing action is achieved. Laser beam, which is coming out of an aperture, strikes the mirror, which is inclined at an angle of 45 degrees, is passed towards the table through a lens and nozzle which is of 1 mm diameter. Let us see about the table motion controller. This system is supplied with gantry motion controller, which controls all X, Y and Z directions. It is also possible to control a theta, which allows a three-dimensional machining. Control may be automatic or manual. It is also possible to control the motion by using a computer through installed software. This software allows the operator to submit the drawings of path and location as well as operating parameters such as pulse width and pulse repetition rate. So about the power supply unit. This power supply unit provides the necessary energy for the flash lamp which enables the lasing action. On this power unit supply, it is possible to adjust the parameters such as pulse width and pulse repetition rate. So about this operation of this machine, in order to start this machine, firstly start a 3-phase AC power supply. It is necessary to operate this machine at the temperature of 26 degrees centigrade. Hence we have to start the chiller accompanied with this system. Once temperature gets stabilized, we can go for further actions. Hence start the table motion controller. In case of an automatic mode of an operation, we have to switch on the computer. Operating parameters can be adjusted by using power unit supply associated. Hence it is required to start the power unit supply separately. Start the flash lamp twice and check the current of 0.5 amperes for each lamp. Further, this allows the system to build a voltage of more than 250 volts. Once required voltage get builds up, we can set the para 002, that is pulse width, and para 003, that is pulse repetition rate. This controller also allows the operator to control the lasing action, that is to start and stop the machine. Selection of the operating parameters depends upon the workpiece material properties and mode of operation of the system. Workpiece material properties includes reflectivity, thermal conductivity and thickness of the material. So various operations such as drilling, welding, surface treatment, engraving, marking, etc. can be successfully done. Mode of an operation decides whether the beam must be at the focus, below focus or above the focus. For example, in case of the drilling, it must be at the focus, while in case of the surface treatment and welding, it must be off the focus. Let us perform the actual experimentation. Firstly, we have prepared the samples by cleaning with acetone and removing the burr by the grinding. Then also we have prepared the samples of the dimension of 100 by 30 mm with the thickness of 0.3 mm. We are holding these workpieces with the overlap of 30 mm by specially designed fixture which maintains a air gap of 3% of the thickness of the material. Now Sudhir is going to give the pulse from the controller.
Ready? Start.
Stop. Actual weld spot is obtained, hence these two pieces must be welded. Weld spot is obtained here, hence these two pieces are welded. We have now removed the workpiece from the fixture and these two pelts are now welded. These two workpieces have removed from the fixture and these have successfully welded. Now these two welded samples are tested for the weld strength on tensiometer. Hence we get the spot diameter as shown on Leica image analyzer. In order to get the microstructure, we have cut these welded pieces on the wire ADM and have mounted by using holding process and then etched and have obtained the microstructure under the image analyzer. This image analyzer shows the penetration depth and spot diameter. Hence in this way we have obtained the maximum weld strength for optimal input parameters and hence we have checked for microstructure.